Hi, and welcome to our new series on mixing C++ and Rust. In this series, we'll discuss first why, but then also how to mix C++ and Rust in a single application. This video will be a high-level overview of both languages and their respective advantages. We'll follow this up with hands-on coding tutorials on how to write a Qt frontend with a Rust backend. If you're already familiar with C++ and Rust features, you may actually skip this video and go straight to the hands-on tutorials. However, if you want to know more about when each language is the really best fit, stick around for a short discussion. Before we talk about Rust, let's actually take a minute to talk about the advantages of C++. We here at KDAB have a lot of experience with C++. It's a very well-established language, it's industry-proven and battle-tested. It's also an object-oriented systems programming language, which may be what you want, especially compared to C. It also comes with a large existing ecosystem, and there's a lot of senior developers out there, which can make hiring a lot easier if you're looking for someone very experienced. Also, C++ supports pretty much all platforms under the sun, even the most obscure ones. And most importantly, your app is probably already written in C++ and not in Rust, so why throw all of that good work away? However, if you are looking to either write a new component or to build a completely new project, you may want to consider Rust due to its advantages. It's the kind of new kid on the block, if you so want. It can be seen as a successor to C++, but it's also taken a lot of inspiration from other languages like OCaml, Haskell, Ruby, and many, many more. The most important feature compared to C++ is that it has safe memory access through the borrow checker, with unsafe access if needed, so you still get access to everything. This means that you can prevent most security vulnerabilities by this, because most of them are actually caused by memory issues. If you're a developer, this basically means you get no more seg faults. This is also especially important due to increasing regulatory pressure that is coming especially from the EU and the United States. You also get all of the modern abstractions that we've come to love with C++ by default. You get smart pointers, you get really good error handling. And you also get first-class multi-threading that is even better than in C++ because it can basically eliminate all race conditions. It also just comes with a modern build system and package manager, which is a lot more developer-friendly, and it's a lot easier to get started with, especially for all of your developers that are new to Rust and even to systems programming. So because both of these languages are actually such a good fit, there are already a lot of different options available to bridge between the two languages. First, and probably most obvious, is what's called extern C. That's kind of the default foreign function interface in both Rust and C++ and many other languages. The downside, though, is that it's limited to C's functionality, and the resulting functions from a Rust perspective will actually be unsafe to call, which can make your Rust code a lot less idiomatic. This is why in the next video, we'll actually take a look at a library called CXX. It is meant to safely bridge C++ and Rust code and allow you to write much more idiomatic code in both languages while still bridging to the other. The idea here is that you write an API description, which is sort of similar to a C++ header file, that is compatible with both Rust and C++, in the form of what CXX calls extern C++, but also extern Rust blocks. CXX then generates the appropriate bindings for both languages, which are then also checked for compatibility and safety at compile time, which takes out a lot of the guesswork and safety concerns about bridging the two languages. At KDAB, we have actually built on top of CXX to build CXX-Qt, which allows us to add Qt to the mix. It's still an API description, but allows you to also express Q objects, Q properties, signals, slots, and all the other Qt features in that description. This enables you to use Rust as a backend language for your Qt applications, especially if you're using QML frontend. This is a great fit. For a more comprehensive discussion, you can also watch the keynote from the Oxidize conference on C++ migration strategies by our CCO Till and Ferris System co-founder Florian. We actually also have a few written resources on this topic already. You can find some of those in our blog, but also in our white paper on building hybrid Rust and C applications. So I can really recommend that you check these out. Because both of these languages are such a good fit to use together, we at KDAB have actually already worked on quite a few projects that use this. First of all, we have actually integrated Servo using CXX-Qt. While the Rust ecosystem is still young, some great libraries already exist. One of them is Servo, an embeddable, lightweight web engine that is completely written in Rust. Even though Servo is not yet production ready, we've still managed to embed it into a Qt and C++ front end to create a demo of what's possible if you combine some of the best that the C++ ecosystem has to offer with some of the best that the Rust ecosystem has to offer. Our example runs on a Raspberry Pi 4. It's a very good demo that uses very few resources and is very quick to compile and deploy. We've also collaborated with Slint and SK-Signet, where we can actually find a production project that uses Rust and C++ in the same application. SK-Signet is a leader in EV charging technology, and they partnered with Slint and KDAB to develop their next generation UI for their high-speed chargers that are now being deployed. Their new frontend combines a Rust frontend made with Slint with a C++ application that is providing the data for the Slint frontend. In this case, Slint actually already provides the bindings to C++, and for the developers on that project, it almost looks like there's no Rust code to be found, so it's very transparent. Slint have actually also developed a demo that's on the other end of the hardware spectrum, that's running on the Raspberry Pi Pico. That whole hardware setup can be found for about €5 or €20 if you include the screen. While this example only uses Rust and no C++, because Slint provides these C++ bindings, we can actually really easily replace that backend with a C++ backend. So we've talked about why mixing C++ and Rust is a good fit. Next time, I'll show you how to actually do it on a technical level. I hope you enjoyed this video. Consider subscribing so you don't miss the next episodes, where we'll go hands-on with CXX and later CXX-Qt. Bye und bis zum nächsten Mal.